Good morning. Welcome back to brake system lectures. Uh, in previous lectures, we have done this problem. I asked you to do the problem, the second problem, a four-wheel automobile aspect. Hope you would have done that. If not, I will do it again. And also, I would like to emphasize the important thing. This is a free body diagram where we just few important points I would like to emphasize. This is the pivot, okay, this is the pivot. From the pivot to where the lining starts, right, this is the lining starts, that's a theta, that's a theta 1, yeah, that's a theta 1. And right, so from the pivot position to where this is going to be, then theta 2 from the pivot to where the lining ends, that is theta 2. Please aware of that, that is very important. And also I have mentioned very clearly the center of your brake drum to the center of pivot, the distance, horizontal distance is h, yeah, and from the pivot where the activation force act on the tip, the distance is c, okay. R is the radius of the drum, that is already you know that. And these are the things just I wanted to make sure that understand. Sometimes we may get confusion. To avoid that, just I am emphasizing. And also I would like to emphasize two things, right. The activation force, this is what I said. When you take the moment, probably I can go back here. So with the rest, this is the pivot, you keeping this reference to pivot. When this load acting, right, this is load acting, you will have moment. There are two type of moment. One is normal moment and frictional moment, right, that is what I said. So we derived both moments and also we try to do the balancing. So we end up P equal to activation force equal to Mn because of the direction minus F by C. This is reduce your braking effect. That is why we said reduce in the sense the magnitude of the braking effect will be less or efficient, I would say that. So that is why it is called a self-analyzing effect, whereas the magnitude of activation force would be this is called a leading shoe. I am sure you know that this is the leading shoe, yeah. Then another one, when the activation force that is separate, when the activation force Mn equal to when activation force is 0, obviously Mn equal to Mf. So obviously you can't run, so you will have a stalling. Only the wheel runs, the vehicle won't move. So that is not advisable. The third aspect where the sign will change. So that means you need to have a more activation force Mn plus Mf by C. This is for trailing shoe. This is for the trailing shoe. And the moment you do reverse direction, what happened to the arrangement? The trailing would be leading, the leading would be trailing. To avoid that, we will have a leading with the two wheel cylinder, that is one arrangement. And as DO also we have done that, DO things. And also I would like to show the these are the shoes, you can see that, okay. These are the two shoes. Okay. This is actually drum brake system, right. Can you tell me, are the both are leading and trailing or leading and leading? If you look at this arrangement, it is a leading because of there is no short length of brake lining. I can say this is the brake lining, and this in fact this is Honda Activa two-wheeler brake shoes. It is from my vehicle. Okay, this is from my vehicle. Maybe I can circulate, you can see latest stage. Right. So you can see where is the pivot is coming here. Which position pivot? Yes, this is which arrangement? Normally this is the arrangement, right? This is what happening. The wheel cylinder will be there, and you can see that the brake lining starts and this ends, right? So you can see in detail later stage. Let's move on to the next problem. Yeah, an automotive type internal expanding double shoe brake is drawn in class. I am going to draw now. Okay. The face width of friction lining is given 40 mm and the maximum pressure intensity of normal pressure is limited to 1 Newton per millimeter square. The coefficient of friction is 0.32. The angle 1 theta can be assumed to be 0. Calculate the activation force, the torque absorbing capacity of brake. These are the things you have to do that. So, perhaps I will draw the diagram first. So, note down theta 1 is 0, okay. The data is given. The P max is given. The maximum P max is given as a 1 Newton per millimeter square, that is given. W is the width of the friction lining is given as a 40 millimeter, and the mu is the coefficient of friction is given as a 0.32 and theta 1 equal to 0 degree, and in the I will draw the diagram, then you will see what other values are given. Okay. Just not to scale, just for understanding purpose. So, we have a pivot here, the pivot will move like this. That is a pivot. Then the friction lining also will be there. The friction lining is fully attached to the wheel drum. Okay, that is a friction lining. Then I will draw the central line. Okay, then there is one more pivot. Right. Now the activation force acts in both ways, right? We are showing only one direction, but I can show both ways. This is your activation force, yeah, this is activation force. So, now I will give the information. What other information? From the pivot where the friction lining starts, okay, friction line start and ends, right, the ends is 120 degree, is 120 degree, okay. Then from the friction line ends to the this position is 30, right. Then so 30 plus 150, then this should be 30 degree, right. From here to this position is 30, okay, that is given. Then just wanted to show the H value from the center of the drum to the center of the pivot, the dimension is given as a 50, okay. Then activation force, we need to find out the activation force from the pivot to, right, till this position, right, pivot to here. So, the entire thing will be C. I will give you a split up. This is 86.6, okay, and 100.9. So, the C value 86.6 plus 100.9, that is the value is given. The R is given. R is not given, right. The radius of drum, brake drum is not given. So, radius of drum is 125 millimeter. 125 millimeter. So, the question is clearly asked, find out the activation force P and also torque absorbing for the brake. That is what you are supposed to do that. Yep. Okay. So, theta 1 is 0, already we know that theta 1 equal to 0 because straight away start from the pivot, right, pivot to here is straight away started. Then theta 2 equal to 120, that we got it from here, Okay. Then how about theta max? Generally abusive sin theta max will be sin theta max is equal to 1, cannot go beyond 1, that's already given. Now with the geometry h, I just wanted to find out what will be the h. Okay, so 86.6 square plus 50 square. If you do that geometry aspect, if you do the geometry, you know the distance here, you know the distance, right? And I you know the distance. From there, if you are able to substitute, and you will get h equal to 100 millimeter. Okay, that's 100 millimeter. So the activation force, it's assumed that the maximum normal pressure will occur between the lining and the right hand shoe and the brake drum, because we are focusing only on the leading shoe aspect. Okay, this is your shoe, right, and this is your friction lining, and this lining exactly interacting with the drum, right. So where do you expect the pressure? In this position, right, the pressure you would expect in this area, this is where it's happening. Yeah. So now the step will be, we need to find out the with respect to pivot, respect to the activation force, the MF as well as Mn you need to find out. Those equations already are given to you. Okay, those equations already are given to you. Can you find out, please? Maybe I'll write down the equation MF. MF equal to mu P max radius of R, okay, W, then is a 4R cos theta 1 minus cos theta 2 bracket open minus H cos 2 theta 1 minus cos 2 theta 2 whole divided by, okay, whole divided by 4 sin max. This is what we given. So we know mu equal to 0.32, and maximum pressure we have taken 1 meter Newton meter per millimeter square. We will substitute everything in millimeter. 125 R is the radius. The width is given 40 millimeter. Okay, clearly given. Then if you substitute other values, right, can you substitute, then divide by 4, maximum sin theta max we have taken as a 1. Substitute the values, please, and if you substitute the corresponding the value 4 into 125 cos 0, right, theta 1 equal to 0, then cos 120, right, minus of 100 cos 2 theta, that means again 0, 2 theta 1, then this should be cos 2 into 120. Yeah, so that will give you the closing up. If you substitute, what is the value you are getting now? You would expect, okay, you would expect 240,000, right, so much Newton a millimeter. This is MF. This is the value you must. Did you get this value? Right, you should have get. Now similarly, this is for MF, right. Now I'll go for Mn. Again, this is the from the pivot, with respect to pivot, when the P tip acting on the tip, so where you will get a normal moment. Again, this would be P max or WH, okay, 2 theta 2 minus theta 1 minus of sine within the bracket sine 2 theta 2 minus of sine 2 theta 1, close the bracket, divided by, okay, 4 sine theta max. Similarly, substitute all the values 1, 125 and 125, this should be 40, h will be 100, right. Then you substitute the value theta 2 equal to 120, theta 1 0, minus of sine 2 into 120, right. Then sine 2 into 0, 4 sine max theta max equal to 1. Then you would expect the value 631,851.95. Okay, maybe approximately we will do as a 631,852 Newton millimeter. So this is Mn. So we got from the leading shoe, right, both Mn and Mf, we got it. Okay. So now we need to find out what would be the torque absorbing capacity. Yeah, torque absorbing capacity. So now I want to find out with respect to MT on the right side, okay, which is the leading one, equal to mu r square P max W cos theta 1 cos theta 2 divided by sin theta max. Okay. So substitute again, this is coefficient of friction is 0.32, 125 whole square, P max 1 and W 40, right, cos 0, cos 120 and sin, sorry, I can substitute straight away 1, right, max is 1, nothing else. Are you getting your MT torque absorbing capacity on the right hand side 300,000 Newton meter. So this is the value you should expect from MT. MT is nothing but torque, okay, torque on the right side. So can we find out what will be the activation force? P equal to, for the leading shoe, okay, we will find out. Can I move on? Right. The activation force for right side shoe, okay, nothing but leading shoe, we are assuming as a leading shoe, P equal to M N minus MF by C, right. So you know the value, what is the Mn? Mn already we know that 6, right, 631,852 minus 2400, this is the one, divided by, what is C value? C value, what is the C value? It 187 point, okay, 187.5. So can you tell me what is the activation force you are getting? Are you getting 2089.88? You would expect 2089.88 Newton, that is the activation force you would expect at the tip of the shoe. as a tip of the shoe. Okay. The question so far we are focusing only on the leading shoe aspect. My question would be, what do you expect on the trailing shoe? Do you expect that activation force would be equal? That is one question, right, or different? And what happened to your M and MF value? Are they will be different or same? Okay, that is another question. The third question, the pressure is given, that is the maximum pressure is you would experience between the lining and the drum surface interface, right, that is there. So, would you expect the same pressure that would occur on the trailing shoe? So, how to proceed? How to proceed? You understand, right, my question? The three question, do you expect the activation force would be same for the trailing and leading? That is one question. The second question is, do you expect the M and MF are same magnitude for both leading and trailing? So, the another question. The third question, do you expect the change in the pressure between leading and trailing? The reason why I am saying that, for as long as for trailing shoe aspect, the activation force should be higher, right? Right? P equal to Mn plus Mf by C. That is what supposed to be. So, how can we proceed? Yeah. So, if I want to match that, okay, because if I want to maintain my activation force for leading and trailing, right, differently, if in that case, right, how do I, what parameters do you think will change? Which parameter would change? Yeah? Louder? No, they are same. Yeah, okay, assuming now the same, assume that is a, we take it out. In fact, we do not know what exactly the pressure is acting on the left hand shoe, trailing shoe, we do not know the pressure. Okay, I will give you information. So, the maximum intensity of pressure for the left shoe is unknown. For identical shoes, that is what I said. That is why you nicely say theta 2. No, I am giving as an identical shoe. For identical shoe, from M and MF both proportional to the P max, exactly. One of the assumption, your P max is variable from the position of the pivot to as you move vertical direction. That is the one of the assumption we have taken. Okay, right. For the left hand shoe, the maximum intensity pressure is, we will take it as another P max, right. We will take it as a different shoe. For the left side shoe, we will take a maximum pressure is different. The maximum pressure, we take it as a dash P max, that is what you will say that. Okay. So, therefore, we know that your MF dash will be proportion to the force, right, the proportion to the what force you are expecting. Already I know my P max equal to how much? 1 Newton per millimeter square, which already given to us. So, based on the proportion of the pressure on the leading trailing shoe, the corresponding MF and Mn would change. So, this is 2040, right, that is P max dash by P max, that is one relationship we got. So, straight away MF dash equal to, this is 1, right, this is 1 Newton per meter square. So, you can say 2400, 240,000 P dash max, that is one thing we have equation number 1. Similarly, same for the Mn dash also, Mn dash would be 631,852 P dash max, that is equation number 2. Okay. So, for left hand shoe, left side shoe or left hand shoe, doesn't matter. Your P equal to M dash F by C. This should be okay. Now let me ask question. I'll ask one question. You have seen the video. You have seen the video, right? So when you press the brake pedal, the right due to vacuum and the master cylinder will release the fluid, brake fluid. The brake fluid will follow through the brake lining, the brake path, then it will distribute to the front axle and rear axle. Okay, assuming that. So we will assuming only at the rear axle at the moment. So when it goes to rear axle, will take the one wheel, left side wheel will take it. Right. So left side still will fit it with the drum brake system. So we said identical shoe. So you will have a one cylinder only. When you have one cylinder, the braking fluid, a pressurized braking fluid will try to move the piston equally, right? The piston is a double acting piston. So it will equally display such a way that the activation force should be equal on the leading shoe as well as trailing shoe. That should be equal. Okay. So when you have equal, what happened to your Mn dash, Mf dash? That's one thing you need to understand that. Okay. So but already I know that. What is the what I know? I know what is the p value. What is the p value we got earlier? So what is the p value we got? I am sorry, 20 2089, yeah, 0.88, approximately we can make 2090 Newton. You do that, activation force is given. Okay. So activation force already we have that. Okay. So can you what will be the new P max dash? How will you find out now? Will you find out now? Right. So we know P value, we know the C value. Then how can you find out the MF and MF dash or Mn dash? That's what my question. Yeah. Yeah. I'm sorry. Yes. Yeah. Okay. So then I'll move on to the another aspect now. The another aspect. How about the torque activation? What will be the torque activation? What will be torque activation? Yeah. See, please understand. I just want to repeat again. Your P equal to dash Mn dash this F, right, by C. This is given. Already I know what is that Mn dash here. 631, 852. I just make it as a round value. Mf dash F, what is that value you are getting? 240, right? 1000 so much. In fact, sorry, this should be P dash max, so much Newton meter, right? So much Newton meter. Just put it in a bracket. This also Newton meter, right? So already I have substitute this value. Already I have substitute this value, and I will also substitute this value. So can you bring everything with respect to P max dash? Right? Can you do that? Can you tell me what will be P max dash now? What is that value? Excellent. So we have a 0.45 Newton millimeter square. Right. See, remember, the activation force should be equal, no matter whatsoever. That has to be equal, right? If you want to make equal, what happened to your pressure? Pressure will change, right? This is what I wanted to convey, right? So when the pressure is changed, obviously now if you substitute this value, you will get the value. What is that value here? And can I have the value please? Now you know that 0.45 is given, so you know what will be the your moment, normal moment and frictional moment also you will find out. Okay. So what is the value you are getting? Which one? Yeah. 108,000. So much Newton millimeter, right? That's clearly given. Okay. What about your Mn dash? 2? 333. Okay. That's fine. Leave it 0.4. Okay. Now can you see that your Mn dash, Mf dash are different, right? Your Mn dash, Mf dash are different. Okay. Because you have to satisfy. You have to satisfy that. Then one more important thing, the torque we are talking about. We need to understand about the torque, the activation torque. The MT, that's also will depends on the your proportion of the pressure. Your MT on the left side. Okay. Yeah. So we know that what is the torque, we got it from leading shoe 300,000, right? 300,000. So again it will be proportionate of the pressure, proportionate of power, pressure, P max, P dash max and P max. So tell me what is the value you are getting now? MT equal to, for the left, into 0.45. When you do that, I would expect 135,000 so much Newton millimeter. Okay. Maybe I will rewrite one more time. You have MTR. What is MTR? MTR 300,000, right? 300, so much Newton millimeter. MT left, just now we got 135,000, right? 135,000 Newton meter. Now can you see what happened to your torque now, frictional torque? It varies, right? Because of the pressure varies, obviously the torque also varies. So the question is, it is asking the total torque absorbing capacity, the total torque absorbing capacity. That means this is for the leading shoe, right, and this is for trailing shoe. Now we need to know the entire brake, leading and trailing, right, that is MT 300,000 plus 135,000 should be given me 435,000 Newton millimeter, or else 435 Newton meter. So this is the total torque acting on the entire absorbing on the brake system. Okay, is it clear now? Yeah. So quite obvious, you are applying the brake through the pedal, right? The brake fluid goes through. In drum system we have wheel cylinder, so the brake fluid, pressurized brake fluid will activation force equally on the both tips. Okay, but we know that the braking effort will be much better in the leading shoe, whereas you need to have more on the trailing shoe. That can be achieved due to the pressure variation, right. So by when pressure changes, obviously the corresponding momentum of normal, momentum of friction will change. Because of that, the torque also will change. Okay. Now do you understand why how the leading and trailing shoe functions, right? So and also another is posing another effect, another thing. instead of having trailing, if you have the trailing shoe replaced with the leading shoe, then the braking effort will be much better, more effective. Okay. I think I will stop now. So, we will continue on tomorrow. Thank you.